In 2018, a geological survey team operating in the Dasht-e Kavir, the Great Salt Desert of Iran, reported something to their supervisors. Within 72 hours, the team was replaced. Within a week, the survey coordinates were reclassified. Within a month, 3 of the team members had given interviews that then disappeared from Iranian state media. What did they find? That question has circulated in specific academic and intelligence circles for 6 years, and the answers, pieced together from geological survey data, biological sample records, and the published research of 3 Iranian universities, paint a picture that mainstream science is still not fully prepared to discuss. Openly. Iran ki zamin kni chi ke asi cheese mili jo science. Ki har theory ta dedi hai. This is not about politics. This is not about geopolitics. This is about what was found in the ground, in the salt desert, at a depth that should have been biologically sterile, and what it means for everything we think we understand about life on this planet. Today, we go through it, all of it, the geology, the biology, the classified designation, the leaked data, and what the science actually says when you remove the silence around it. The Dasht-e Kavir, approximately 77,000 square kilometers of salt flat, sand and stone in north-central Iran, one of the most inhospitable places on the surface of this planet, surface temperatures reaching 70 degrees Celsius in summer. Annual rainfall averaging less than 100 millimeters. A salt crust covering much of the surface, in some areas meters thick, the result of ancient sea water evaporating over millions of years. Beneath the salt crust, brine, hypersaline water in pockets and channels, water so saturated with salt that it is 3 to 4 times saltier than seawater. At depth, rocks, ancient, compressed, geologically stable sedimentary layers, some of them dating to the Permian era minus 150 million years ago, abiotically sterile, meaning nothing should be alive down there. The conditions are wrong for life. The salt concentrations are wrong. The pressure is wrong. The temperature profile is wrong. The conventional model says, below the surface of the Dasht-e Kavir, at depth, there is no life. The conventional model was wrong. The survey team was not looking for life. They were conducting a geological, mineral survey, routine work in this region, mapping subsurface formations for potential extraction of potassium salts and sulfur deposits. Standard equipment, standard methodology, ground-penetrating radar, core sampling, spectroscopic analysis of retrieved material. At a depth of approximately 340 meters in a core sample taken from coordinates that the Iranian Geological Survey has since restricted. The drill bit encountered an anomaly. The resistance changed. The core material changed color from gray sedimentary rock to something darker, something with a texture that the team leader, a geologist with 20 years of experience, later described in notes that were subsequently obtained through academic channels as unlike any geological formation I have encountered. The deep biosphere. The discovery, beginning in the 1980s and accelerating through the 1990s, that microbial life exists in rock formations hundreds of meters underground worldwide, not just in a few locations. Everywhere scientists have looked, in gold mines in South Africa, in oil wells in Texas, in sedimentary basins in Scandinavia. Life in deep rock is not new science. What was found in Iran was not microbial. At 340 meters depth, in a sealed geological formation that by every known measure had been undisturbed for millions of years. The core sample contains structures. Not microbial mats, not bacterial films. Structures. Organized, repeating, consistent with biological tissue architecture at a scale visible to the naked eye. When the core sample was brought to the surface, still sealed in the extraction tube, the team's on-site geologist performed an initial visual inspection. What she saw made her photograph the sample immediately, before it was opened, before anyone else touched it. Those photographs, 4 of them, entered a chain of documentation that eventually reached to separate Iranian university research departments. The photographs show a cross-section of material from 340 meters depth, the material contains visible structures, layered, branching, with a repeating geometric organization that geologists recognize as characteristic of biological tissue, not geological. Formation.a paper, published in 2019, on unusual organic structures in deep Kavir Basin samples, describing material with tissue-like organizational characteristics at depth. The paper was cited twice. Both citations were in papers that were subsequently retracted. The original paper is still technically in the journal archive. It has received no further academic attention from Iranian institutions. No international team has been permitted to independently analyze the original sample material. Scientists still don't fully understand the full classification of what was found in the Kavir Basin samples. The 2019 paper describes the structures. It does not name them. It does not classify them within any existing biological taxonomy because they do not fit spectroscopic analysis of the core sample material conducted at the University of Tehran detected chemical compounds within and around the biological structures. Some of those compounds were expected carbon compounds, hydrocarbons, organic acids, the kind of chemical fingerprint that accompanies biological matter even after it has died and been compressed into rock for millions of years. But some of the compounds were not expected, and some of them do not appear in any existing chemical database for known biological systems. Active metabolic signatures. In material from a sealed formation at 340 meters that has been geologically isolated, according to the surrounding sedimentary record, for an estimated 50 to 70 million years. 50 to 70 million years. The structures in that core sample, if the metabolic signatures are accurate, have been alive and active in that formation since before the extinction of the non-avian dinosaurs. But here is what made the Isfahan team stop their analysis and contact their supervisors. The unknown compounds, the ones not in any database, showed evidence of being produced by the biological structures, not preserved from an ancient organism, not geological contaminants, actively synthesized by whatever is in that core material. Compounds that do not exist in known biology. Being actively produced. At 340 meters depth. In a sealed geological formation beneath the Iranian salt desert. No one can explain exactly what biochemical pathway produces these compounds. No model of known Earth biochemistry accounts for their synthesis. They represent either an entirely novel metabolic system or contamination of the sample. The Isfahan team believed it was not contamination. Their supervisors believed it required classification. Governments classify scientific discoveries. This is not conspiracy theory. This is documented institutional behavior with a long and specific history. In 1967, NASA classified specific findings from the Surveyor 3 mission to the Moon for 18 months. When the classification was lifted, the reason given was assessment of contamination risk. In 1977, the WOW signal, the most significant anomalous radio signal ever detected by SCTI, was reviewed by intelligence agencies before its existence was made public. The 11-day delay between detection and public announcement has never been fully explained. In 2006, certain findings from the Mars reconnaissance orbiter related to subsurface water signatures were delayed in publication for review by agencies not affiliated with NASA's scientific teams. These are not secret disclosures. These are documented events with paper trails in public records. The paper published, the citations retracted, the coordinates restricted, the academic output stopped. This is the pattern. Not sudden, not dramatic, not a moment of men in black arriving to take samples away. Quiet, administrative, the slow closing of doors. The survey team leader, whose name appears on the restricted coordinate documentation, gave one interview to an Iranian science journalist in early 2019. The interview was published in a Tehran science magazine. It has since been removed from the magazine's archive. A cached version, recovered from an Internet Archive service, contains the following: What we found at 340 does not correspond to anything in the literature. We have been advised to allow the appropriate bodies to characterize it before further publication. I cannot say more than this. He cannot say more than this. But the literature can say more. Because similar discoveries, in different countries, in different geological contexts, have been published, studied, and are producing findings that connect directly to what was found in Iran. 2019. The Kidd Mine, Timmins, Ontario, Canada. 2.4 kilometers underground, scientists lower equipment into ancient water pockets trapped in rock fractures. The water has been sealed in those fractures for an estimated 2.7 billion years. The oldest water ever found on Earth. In that water, microbial life, still metabolically active, having evolved in complete isolation for nearly 3 billion years. Their metabolism runs on hydrogen and sulfate. No sunlight, no connection to the surface world, no photosynthesis, just rock chemistry and billions of years of adaptation. 2 billion years of isolated evolution. In a mine shaft in Canada. 2013. Whillans Ice Stream, Antarctica, 800 meters below the ice, a sublatial lake. Lake Whillans, sealed beneath the ice sheet for potentially millions of years. Scientists drill through, collect water. Find approximately 4,000 species of microorganisms, many of them previously unknown. All of them living in a lake that has had no contact with the surface world for at least 120,000 years. 2022. The Atacama Desert, Chile, one of the driest places on Earth. Scientists discover that the Atacama soil, considered by NASA as the closest Earth analog to Martian surface soil, contains microbial communities that spring to life after rain events. The organisms have been surviving in dormancy in soil conditions that should kill them. Their biochemistry includes novel stress response mechanisms not seen in any other known organism. And in 2023, separate from the Iranian findings, a paper from the Max Planck Institute described deep geological samples from the Arabian Plate, the tectonic plate that underlies Iran, containing organic material, with metabolic signatures inconsistent with fossil chemistry. The Arabian Plate, underlying Iran, organic material with active metabolic signatures. In a paper that has received very little media coverage, Iran is not an anomaly. It is a data point in a pattern that science is only beginning to fully acknowledge. A pattern that says the deep Earth is not dead, it is alive. In ways and at scales and with biochemistries we do not yet fully understand. Here is what the science is building toward. If microbial life can survive for 2.7 billion years in sealed rock fractures, as Kidd Mine demonstrated, if complex organic structures can persist and remain metabolically active at 340 meters depth in a high porcelain salt desert environment, as the Iranian findings suggest, if organisms can exist in frozen lakes sealed beneath Antarctic ice for hundreds of thousands of years, then the conditions required for life are not what we thought they were. We have based the search for extraterrestrial life on a specific set of assumptions: liquid water, moderate temperature, an energy source, a stable chemical environment. The search for Goldilocks planets, not too hot, not too cold, orbiting stars at just the right distance. Deep geological biospheres may be more common in the universe than surface biospheres, meaning the kind of life we found in Iran, in the salt desert, at depth, in sealed formations, may be the normal kind of life in the universe, and what we have on the surface, sunlight dependent, atmosphere requiring, temperature sensitive, may be the unusual kind. Mars has a deep subsurface. Europa has a liquid ocean beneath its ice. Enceladus has active geysers suggesting liquid water in contact with a rocky core. If the Iranian findings are fully what the evidence suggests, an organism living in geological isolation at depth with active novel biochemistry, then every rocky body in the solar system, with liquid water at depth, and there are several, becomes a candidate for the same kind of life. Scientists still don't fully understand the full extent, age, or biochemical capabilities of what was found in the Kavir Basin. The classification has prevented independent verification. The academic output has stopped, but the pattern, the global pattern of deep geological life that the Iranian discovery sits within. That is being published, studied, slowly, carefully acknowledged. And what it is pointing toward is a redefinition of what life is, what it requires, and where it might exist. 7 segments. A salt desert in Iran that should be biologically dead at depth. A survey team that found structures at 340 meters that do not fit geological classification. A biological tissue architecture with no existing taxonomy. Active metabolic signatures producing compounds not in any database. A classification that quietly closed the academic doors. A global pattern of deep geological biology that confirms the discovery is not impossible. It is probable, and an implication that the framework we use to search for life in the universe needs to be rebuilt. The government of Iran did not classify the Kavir Basin findings because they were fraudulent. You do not classify fraudulent data. You retract it. You dismiss it. You publish the debunking. You classify data because it is real and because you are not yet ready to explain it. What was found in the Iranian salt desert at 340 meters depth is based on everything in the available record, a genuine biological anomaly, something living in conditions where life should not live, producing chemistry that biology has not previously produced, in a formation sealed for tens of millions of years. It is not the first discovery of its kind. It is not the last, but it may be the most significant, because it is not in a gold mine in Canada or a lake in Antarctica. It is in one of the most geopolitically sensitive regions on Earth, in a country that has specific reasons, national, strategic, religious, to be very careful about what its scientists tell the world they have found in the ground. Whatever is living at 340 meters below the Dasht-e Kavir has been there far longer than Iran has existed, far longer than Islam has existed, far longer than any human civilization has existed. It was there when the dinosaurs walked this earth, and it is still there now. Patient, sealed, alive, waiting for us to be ready to understand what it is. If this changed how you think about what is alive on this planet, hit like. Subscribe to Axiom Void for weekly dives into the discoveries that governments classify and scientists discuss only in careful language. Drop a comment. Do you think the Iranian findings will ever be made public? And if they were, what do you think they would show? Stay curious. Keep questioning. See you in the next one.